Oh, it was a 9.3.
Oh, 9.3. Okay, no problem.
Oh,
Yeah, 9.2 is something else to me.
Okay, 9.3. Which number?
it was the last one of 9.3. Okay. Yes, that's the one it was. Because 9.4 was easy. The last one of 9.3, however, even the video didn't help me. And the video was the exact same thing. I
Is this
just
the
didn't know
one?
what to. That's how it had to be?
Okay, is this the one you're looking for? Number 7?
Okay, I didn't know what form they wanted it in.
Okay, so
Okay, I
so
don't
you
need
just
anything
didn't know
else.
how to put your answers. Yeah, you
Right,
just.
and yeah.
But Terika asked me same thing yesterday. She texted me yesterday. I mean, she asked questions through WebAssign, and there was her question too. She knows that P has to be greater than 1, but she didn't know how to put the answer. So you just need to put your answer to be. That's I understand. So you need to put just 1 comma.
I already got it wrong too many times, so
So
I
that
just have to
case,
take an
you
L.
understand now. That case, just send me a through through WebAssign and say, Dr. Harris, number 7, can you manually give me a credit and give me the correct answer? All right.
All right.
So this is, I know I think you guys put your answer to be like this, didn't you? Because that's what we've been talking about it. But
Right, and I think that's what the video said to do.
I'm sorry?
That's what the video said to do.
Oh, okay.
Like when you click to watch
that's what I'm saying. If you put it like this, definitely I'll give you credit because it's just the question didn't literally says, it doesn't say you have to use interval notation. So writing this is exactly the same thing. So they're actually same.
All right. All right, then I'm ready for section 5.
Okay, anybody else? Anybody else has questions from homework problems? You may ask from 9.1 through 9.4, that is fine. By the way, class, we need to have exam because you know now for sure that we are going to have a virtual class. That means we have to have exam. So I'm thinking about doing it right after spring break. So Monday we can review, and then Tuesday we'll have a 9.1 through 9.5 exam.
You mean as in like an extra, like we're gonna have the spring break of like week of nothing, right?
For spring break, I'm not gonna give you anything. We're just gonna have a spring break next week. So when you come back from spring break, the Monday, we will have, I don't want to just give you exam, right after you come back from spring break. So I will definitely give you exam on 9.1 through 9.5 on Tuesday, not Monday, but Tuesday. All right?
Mm-hmm.
All right, so are we ready now? We can start 9.5.
Yes, ma'am.
Okay, let's go and start it. I know not everybody's here because I see only 8 people show up. But let's go and start it. If they do need to get in, then I can just submit it. So I'm not doing the regular scheduled one. I'm just open up the one. So hopefully this will last us longer so we can finish our class without stopping middle of the class. All right, let's do 9.5, alternating series. Remember, we learned quite a few things. Like we need to know whether this series, infinite series, diverges or converges. So they're giving us different tools, like a P series, or a telescoping series, or P series, what else? Geometric series. Like they give you different things to utilize to find whether Okay, I'm gonna mute some of you guys. If you're not talking, I'm gonna mute you. Like if you have a questions, you can unmute and you can ask me. All right. So so we're just learning different tools. Like last time, remember yesterday we learned about which tool we learned. What do we learn yesterday? That you will know taking a limit, and then you can see whether this is going to be converges or not converges. Okay. Now we're doing another techniques. It's called alternating series. So if it's alternate, okay, let's go over the objectives first. Today's objective, we're gonna use alternate series test to determine whether infinite series converges. Next one, alternating series remainder, which we're gonna learn about this. It's just a pure calculation. And classify, we're gonna know whether this convergent series is absolutely converges or conditionally converges. And then we have to also realize if you rearrange your infinite series, you may get a different term. So that's what we're going to talk about it today. Our first one, alternating series. Alternating series is simply series that contain both positive and negative. That's why it's called alternating series. All right, for example, let's look at this one. This is a geometric series, and it will converges. We know that because R is 1/2, okay, which is less than 1. We already know it converges. All right, but let's do since this is a negative in the front, you have a negative in the front, it alternates, starting with a positive and then negative, positive, negative, positive. All right. This alternating geometric series, which is R is equal to -1/2. The alternating series occur two ways. Either odd terms are negatives or even terms are negatives. So this is an example of alternating series. I know this converges, but let's just talk about alternating for a minute. Okay, we're just going to talk about what alternating means. Alternating means you go to positive, negative, or negative, positive, negative, positive. That's called alternating. Right now they gave us theorem. We like theorem, okay? Whenever you have a theorem, using that theorem to figure out whether the series will converges or diverges. All right, so alternating series test. If, again, your infinite series is a positive, and alternating series either like this or like that. In this case, the first number starts with a negative number. In this case, starts with what? Positive number. Because -1 to the 1 give you what? -1. -1 to the 1 plus 1 gives you what? -1 to the second, which is +1. So this starts with the positive. So positive, negative, positive, negative. This case is a negative, positive, negative, positive. That's what that means. So in other words, it's alternating series. It's alternating between positive and negative. All right, now, I cannot just use alternating series test unless I meet these two conditions. They said, if you want to use this alternate series test, you have to have these two conditions met. What does it say? The first condition says, make sure that when you take a limit and approach to infinity, that goes to 0. And the second condition is the next term is less than a previous term. Does everybody see me? Does everybody understand? There's two conditions. The limit has to go to the 0, and another one says an plus 1, which is 1 after this term has to be less than previous term. For example, actually, let's look at the example together right here. Let's look at the example. Is everybody doing okay?
Yes, ma'am.
Okay. Now let's look at we are going to we are going to use this theorem to do our work. So let's remember this theorem says the limit has to approach to 0. The previous term has to be less than, the previous term has to be less than the term will come, right? The previous term is previous term is bigger than the one's gonna come after. So the very first term has to be biggest, and the second term is your second biggest, something like that. So it's a descending order. All right, so determine convergence. Determine the convergence or divergence of this term, this series. All right, this series, okay, without, if we just look at this one, you know what's gonna happen, right? If we're just looking at that part, this series is supposed to be diverges, because it's a p to the 1 and p is equal to 1, which is what? Not greater than 1. So you know this one is just a harmonic series, it will diverges. But we're not just looking at to the 1, we have this alternating one, which is a sign change back and forth, positive, negative, positive, negative. So let's just see whether this series is going to converges or diverges. So let's look at the conditions. To use alternate series test, we need to meet 2 conditions. So we're gonna look at this series. So we're gonna do an is, in other words, 1 over n, okay? So I'm gonna replace n to infinity, then you get 1 over infinity, which gives you a 0. So first condition met. Your limit approaches to 0 when n goes to infinity. Now let's look at the second condition. The second condition says, very first term is the largest one. So if I plug it in, so n equal to 1, all right, then I have -1, 1 plus 1 over 1 over 1, which gives me -1 to the square, 1, which is 1. N equal to 2, what do I have? I will have -1, 2 plus 1 times 1 over 2, which gives me -1 times 1/2. As you can see, A1 is larger than A2. So this series is a descending order. So A1 is large. So A1 is largest, A2, A3, so it's not completely descending order, but the first term is what? Definitely larger than what? Second term. So yes, condition met. Is everybody with me? Does everybody understand what I'm trying to say?
Yes.
Yes,
Okay.
ma'am.
Yes.
So what I'm trying to say is, you cannot just use alternating series test unless you meet these 2 conditions. And then yes, it does meet, because we just plug it in. To me, the best way is just try the A1 and A2. Okay, if A1 is larger than A2, then I know the second condition met. Okay, so don't worry about trying A3 or A4. Just try first 2, first and second. If the first one is larger than second one, then the second condition met. Okay,
Dr. Harris, could you work through that second one again?
Okay, the second one right here, this is the second condition, right? The second condition says, make sure that your first term is bigger than your second term. That's what they're saying. So this is my series. So plug in 2 numbers. Just find A1 and find A2. A1 means what? N is equal to 1, right? So I'm gonna just plug it into this. So you get -1 to the 1 plus 1 over 1 over 1, which gives me 1. Now let's look at the A2. What A2 means? N is equal to 2. So -1. So 2 plus 1 times 1/2. So this is -1 to the third power, which is negative number, right? So it'll be -1/2. So now you tell me which one is bigger, A1 or A2? A1, right? Because A1 is equal to
The first
1.
time, bigger than the second
Yeah,
one.
A2 is only equal to a -1/2. Even it's not negative, it's still less than what? 1. So the second condition met. Second condition saying is this, you can think of this as your A1. You can think of this as what? Your A2. So A2 has to be less than equal to A1. That's what that means. Is it clear to you now? Does it make sense to you, Colin?
Yes, ma'am. Yes, ma'am.
Okay. All right, let's look at the, so what can you say now? Since the condition, two conditions met, this condition met and this condition met, so what can I say? I can say what? That this series is what? Converges. So that's another way to figure out whether the series converges or not. So we just learned another way, alternating series test. So if you have this, if the condition meet the first condition and a second condition, then you can say that series converges. Is everybody with me? Does anybody have questions? Okay, is everybody good? All right, let's move on to next one. Next one, alternating series remainder. So I want to know what is my remainder is. So this is what this is about. So alternating series remainder. Convergent alternating series, the partial sum, I call it S sub n, can be used for approximation for the sum S series. The error involved with, I am approximating S using what? S sub n. S is infinite series. This is what? Finite. All right, so I'm trying to approximate infinite series, the sum of infinite series using n terms. So there will be an error, which we call it Rn, okay, R sub n. So R sub n will gives me what the error between the real sum and a partial sum, the infinite sum minus the partial sum. So let's see the theorem says. The theorem says alternating series remainder. If a convergent alternating series, listen to this, alternating series satisfies condition, which means A1 is bigger than A2, then the absolute value of a remainder R of n involved in approximating the sum S by S sub n. So we can figure out this. In other words, that remainder, the remainder is less than A sub n plus 1. Okay, this one, this problem, let's look at the example. When you look at the example, that makes sense, okay? That makes sense. So let's look at the example. So I have this series. That's my infinite series. This is my infinite series. Let's plug it in, numbers. So n equal to 1, you get this. N equal to 2, you get that. Is everybody following me? So n equal to 3, n equal to 4, n equal to 5, n equal to 6, that's what we have. So we just wrote down first 6 terms. Now, series converges by, so now first thing first, let's just see whether this word converges or not, okay? Whether this is converges or not. So if I want to know whether this converges, what do I need to do? I need to figure out 1 over n factorial. Okay, where does this approach to? This definitely approach to what? Excuse me, I mean to put limit of x n approach to infinity, 1 over n factorial, that goes to what? You can think of this way, which gives me what? 0. So the first condition met. And the second condition, I told you to just look at two of them, right? A1 and A2. So A1 is just equal to negative 1, 1 plus 1, 1 factorial, which gives me, okay, this is not the good one, but still. So it gives me 1. This would be negative 1, 2 plus 1, 1 over 2 factorial, which is negative 2. Again, this is what? Bigger than. So A1 is bigger than what? A2. So second condition also met. All right, so that's good. When the condition met, then I can do what I can, then I can use this. Okay, so I need to make sure that I want to use this. Okay, so does everybody understand? Does everybody with me about this? This series converges by doing an alternating series test. Now, let's do the work that we need to do. Now, I want to figure out what is the remainder, what is error. So you can think of, class, this right here, this remainder is its error. Okay, what kind of errors you're going to have? Because I'm figuring out S is what I want. This is what I want. But I cannot find S because it's infinite. So, but I can find S sub n. And then I'm going to use this as my approximation for this sum. So S is not exactly Sn. Are you with me? They're not exactly the same. So you will have a little bit of error. We call it R sub n. All right, so here is what I'm going to do. So we're going to figure out what is the error, the remainder is. So first 6 1, when you do that, you get 1, that's n equal to 1, n equal to 2, dot, 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 it's n equal to 3. And when you do the summation of 6 terms, you get the 6 terms, you get this number, which is equal to 0.63194. All right, next one. By alternating series remainder, I can figure out, I need to figure out this number, A sub 7. A sub 7, okay, not S, it's A. So I'm gonna do, to figure out this number, I need to put into my series, which is -1 to the 7 plus 1 times 1 over 7 factorial, which gives me, so this is -1 to 8, which is just +1. And then 7 factorial means the same as what? 7 times 6 times 5 times 4 times 3 times 2 times 1. So when you do that, that's equal to 1 over 5040, which is same as this number right here. So you just figure out. The remainder, okay, this right here, the error term is going to be less than this number. So now I can say my S, the S is in between. All right, so it wants me to, it's gonna shut us out again, okay? So that means I have to probably stop recording and then start again. It will probably give me a couple more minutes. So now I can figure out my S should be. I don't know exactly what S is, but S is bounded by this number and this number. This is my lower bound. and that's my upper bound. So my S, the infinite series, when I sum them up, that number has to be between 0.06174 or 0.6214. Now, how did I figure this number? By doing what? The summation, which is S sub n plus Rn, or you can say A7, and this is what? A sub n minus A7.
Dr.
All right.
Harris,
Yes.
I understand how you got the second part, like the S minus, when you did the remainder part to find the 1 over 5,040, but I don't understand the top part, like the S of 6. Like, where did that come from?
S of 6. So this
Yes.
is what that means. S of 6 means A1 plus A2 plus A3 plus A4 plus A5 plus A6. That's what that means. So this is your A sub 7, right? I got exactly the same thing. So what's A1 would be? Negative 1 to the 1 plus 1 over 1 over 1 factorial. What's A sub 2? Negative 1, 2 plus 1 times 1 over 2 factorial. That's what I'm doing. So remember your series is this. I'm still using the same series.
Okay.
So I'm plugging it in. N as 1, N as 2, N as 3, N as 4, N as 5, and 6, and that's what I get here.
Okay.
Does it make sense?
Yes, ma'am.
Okay. So this is a very important, by the way. Okay, this is telling you I can find the boundary number of infinite series when I sum it up. Remember, it's infinite series. The series goes all the way to infinity, right? But I don't know exactly what that number is, but I can say, hey, the summation of the infinite series has to be bounded by this number, which is S sub n minus, in this case, it's S sub n minus A7. This case is what? S sub 6 plus A7. And that's very important. I mean, like you just estimated infinite series, sum of infinite series using a finite terms. This case, the 6 terms you used. Okay, is everybody with me? All right, any questions so far? All right, then now let's moving on to next one. So this is what I'm talking about, the absolute, remember when you look at the geometric series, I said, hey, 1 of n is what? Diverges. But we just figured out negative 1 is n plus 1 over 1 of n. This is what? Converges. All right, so that's what I'm going to talk about today, absolute and the conditional converges. All right, occasionally a series may be both positive or both negative, not an alternating series. Okay, a series may have both positive and negative terms, but not be alternating series. Okay, this, you can think of this problem like this. Look at the, don't worry about this part right now, just look at this part. Because, you know, n squared is always what? Always positive. So n squared does not change signs. The sign changed by sin x, the sin n. The sign looks like what? Graph looks like this. So that's a pi. So when sine equal to say 4, which is about here, since pi is equal to 3.14, sine equal to 4, what happened? You get a negative y. So say sine 1, sine 2, sine 3 is a positive, but sine 4 would be what? Negative. And then sine 5 over 25 is a negative. So they are not really alternating positive, negative, positive, negative. It's like positive, 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 and then you have what? Negative, negative, negative. You can have this kind of problems. So everybody understand why this is still alternate? It's still sign changes, but it's not alternating. So this is a good problem. It's just telling you some series may both have a positive and negative, but they're not alternating. Just like this problem, you have a positive, 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 and you're gonna have a negative, 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 and you're gonna have a positive, positive, positive. All right. So both positive and negative terms, yet it is not alternating series. One way to obtain some information about the convergence of a series is to investigate convergence of the series. So we're gonna look at this using absolute value. Let's just look at this one as absolute value, and then we're gonna figure out whether this is going to converges or diverges. So by direct comparison, you have sine is always less than or equal to 1, right? Because you look at your graph, sine. The highest number is 1 and lowest number is what? -1. So sine x is always less than or equal to what? 1. 1 is the maximum number. So I can think of this problem as this. Does everybody agree? So sine n divided by n squared is less than or equal to 1 over n squared. Is everybody following me why that's true? Just look at this graph. Sine never passes 1. That's always less than 1. Okay, 1 to -1. So for example, sine 2 would be less than equal to 1. So it'll be someplace right here. So in other words, sine n divided by n squared with the absolute value is always less than equal to 1 over n squared. So I'm gonna use direct comparison test. Remember that we learned this in 9.3, direct comparison test. So by then I can tell, what can you tell me about 1 over n squared? What happened to 1 over n squared? Does it converges or diverges? And tell me why. If it's converges, tell me why. If it's diverges, tell me why. Because we know this series pretty well. Somebody tell me. Anybody know? Colin, do you know why this is converges?
It converges because p is greater than 1.
Yeah.
Right. It's p is greater than 1. It converges by p series. Remember this number right here, it's more than 1, it converges. So because this one converges, I can say about this one is also what? Converges. From yesterday's lesson says if the the infinite series is positive, okay? And if the larger series converges, then the smaller series is also what? Converges. In this case, this series is smaller than that series. So since this one converges, this is automatically converges. So absolute convergence. If the series, when you put the absolute value converges, you're not learning a new stuff today. Okay, the new stuff is they're saying if when you put the absolute value